Hey everyone, and welcome to another deep dive. We always bring you the most interesting stuff, and today we're going to be talking about AI, but specifically from the perspective of people attending this made-up conference called IPF 2025 in the future. So kind of like time travelers looking back at what happened in the world of AI.
I love that idea.
Yeah.
It's always fun to speculate about the future. And AI especially is moving so fast, it's hard to even imagine what things will look like in a few years.
Yeah, right. But luckily, we've got some amazing sources to guide us. Articles, books, interviews. They paint a pretty fascinating picture of how we got from the early days of like 3D graphics to this crazy world of intelligent computing and how that's shaping AI applications across like every industry you can think of.
It's mind-blowing when you think about it. I mean, one of the things that really stood out to me is the story of NVIDIA, this company that started out making graphics cards for video games. And now they're like the driving force behind the AI revolution.
Seriously. Okay, so let's rewind a bit. Our sources talk about Jensen Huang, NVIDIA's founder. Way back in 2004, he was already asking about new workloads for computing power. And deep learning wasn't even the thing back then,
Yeah.
but he was already sensing its potential.
And that foresight was key. NVIDIA's computing power increased like 1,000-fold in just 8 years. That's crazy.
That is crazy. That's what they call Huang's law, right? It's basically surpassing Moore's law. And it's been fueling these insane advancements in AI.
It's really remarkable, and to think this whole journey started in a Denny's.
You're kidding.
Nope. NVIDIA was founded in a Denny's booth. Can you believe that? They were originally focused on 3D graphics for video games.
It just goes to show you that the most groundbreaking ideas can come from the most unexpected places. But didn't they face a lot of challenges in the beginning?
Oh, yeah, for sure. Their first product, the NV1, was a total flop.
I vaguely remember that. And then there was the intense competition with companies like 3DFX, right?
Exactly. The sources described Jensen Huang as being super aggressive in his pursuit of market dominance, poaching talent, acquiring competitors, all that stuff.
It sounds intense. But it's important to remember that it wasn't just him. Key figures like Chris Malachowski, Curtis Prime, David Kirk, they were all instrumental in building NVIDIA's foundation.
Absolutely. They navigated those early challenges and helped turn NVIDIA into the powerhouse it is today.
And then comes this pivotal moment, the introduction of programmable shaders and the GeForce era. That's when NVIDIA really took over the gaming world.
Programmable shaders were a game changer, literally. They gave developers so much more control over graphics, which led to these incredibly realistic visuals and complex effects.
Gamers went nuts for it. The GeForce series became a massive hit, and it really solidified NVIDIA's position as a market leader.
And they just kept innovating, releasing new products like every 6 months.
Yeah, that rapid pace of innovation was driven by Jensen Huang's leadership style. He's known for being super intense and demanding, always pushing his team to the limit.
There's this funny anecdote about John Petty watching game developers use this super advanced technology for what seemed like really trivial purposes.
It's like they were always searching for ways to push the boundaries of what was possible.
And that drive to push the boundaries is what ultimately led them from gaming graphics to powering the AI revolution.
Okay, but how did that even happen? How did a company known for making video games look awesome suddenly become a key player in AI? It seems like such a huge leap.
It all boils down to parallel computing, this idea of using multiple processors to work on a problem simultaneously.
But wasn't that concept met with a lot of skepticism at first?
It was. People were all about Moore's law, single processors getting faster and faster. They didn't really see the need for parallel processing.
So what changed?
Well, it turns out that NVIDIA's GPUs, those powerful chips designed for handling complex graphics in video games, were perfectly suited for parallel computing.
Oh, wow. So the very thing that made them great for gaming made them great for AI.
Exactly. It was this serendipitous convergence of technology and opportunity. And it's something that I could definitely see being discussed at IPF 2025. How seemingly unrelated fields can intersect to drive these groundbreaking innovations.
That's a really cool point.
Yeah.
So the GPUs were there, ready to power the AI revolution. But what about the software side of things? Wasn't programming for parallel architectures a huge challenge?
It was a major hurdle, and that's where NVIDIA's software expertise came in. They realized that if they wanted to make parallel computing accessible to a wider audience, they needed to create a more user-friendly programming platform, and that's how CUDA was born.
So UEA, that's a name we hear a lot in the AI world. So CUD basically made it easier for developers to harness the power of GPUs for AI.
Exactly. And it coincided with the rise of deep learning, this powerful approach to AI that depends on massive data sets and tons of computing power.
And that's where Fei Fei Lai's ImageNet project